Okay, so last section for this week is 10.1, and it's on solving systems of equations. So what's the difference between a system of equations versus just solving an equation? What's a system? There's usually more than one equation, which also means that there's more than one variable. So it's when you have two or more equations with two or more variables. Okay, for our purposes, the number of variables will always match the number of equations. Bless you. That doesn't always need to happen. The number of variables doesn't always have to match the number of equations, but ours will. Here's an example of something that you have more variables than you do equations. If I asked you to solve that equation, x plus y equals 10, it's one equation, but there's two variables. How many answers are there to this problem? Infinite. Okay, this equation says you have to add two numbers together and get 10. So 0, 10 is an answer. 10, 0 is a different answer. 8, 2, 2, 8. 14, negative 4. Any of those pairs of numbers I just said are solutions. So a lot of times what happens is if you have more variables, two variables, than you do equations, in this case just one, there are usually an infinite number of answers. And if it's the other way around, if you have more equations than you do variables, a lot of times that ends up being a no solution. All right? Kind of like, imagine I gave you 3 lines, and I asked you to draw them. Unless all 3 lines cross at exactly the same point, then there wouldn't be a solution. Okay? Because lines only have 2 variables. And if I asked you to sketch 3 of them, they would all have to cross exactly like this to have a solution. But most of the time, if you just draw 3 random lines, they don't all cross in the same spot. Any 2 of them would have a solution. But when you add that 3rd line in, that would mess it up. Okay, so that's why we're usually going to keep the number of variables and number of equations the same. Okay, this I don't want to solve it. I just want to set it up. Okay, so you should have enough information, knowing formulas for perimeter and area of a rectangle to set this up. It says, find the length and width of a rectangle if the perimeter is 100 and the area is 300. Okay, so let's start with the formula for area. What's the formula for the area of a rectangle? Yeah?
Length by width.
Yeah, so the area is length times width. And what did they tell us the area is? 300. So I'm going to fill that in. L times N. That's one equation. Now, if that's the only equation you had, how many numbers can you think of that you can multiply together and get 300 as an answer? How many? Quite a few. How many is quite a few?
A lot. 10.
10? More than that. Yeah. I want the exact term that would describe how many answers there are to that. It's infinite. There's infinitely many numbers that multiply together to give you 300. Okay? But they give us another fact, and that's what's going to narrow it down. The perimeter is 100. What's the formula for the perimeter of a rectangle?
2y plus 2y.
Yep. 2L plus 2W. And they tell us the perimeter is 100. So as far as setting it up, that's all you do to set it up. You have to make sure you use the same letters in each equation. You can't use different letters. So we used L's and W's on the left, L's and W's on the right. Okay. Any questions on that? Okay, so the two methods we're going to use to solve systems are substitution and elimination. So once I talk about substitution, we're going to come back and do this problem. Okay, some problems are set up so that you can do elimination. That's usually faster if it works out nice. Substitution can take a little longer, especially if you have more than 2 variables, like 3, 4, 5 variables. Substitution can take a long time. This is a problem that is really set up to only solve a certain way. Out of the 2 methods I have right here, you can only use one of them to solve this problem. So we'll talk about which one it is, and then we'll come back and do it. All right. So can somebody remind me, what's the basic idea of substitution? What do you have to do? Jack?
Cross cancel.
What do you mean?
Like, you try to limit one variable to one side.
Okay, so you try to isolate a variable in one equation, and then what do you do after you do that? So that's actually the first step. Pick an equation and solve it for a variable. And you have 4 choices. You could pick the first equation and solve it for L, pick the first equation and solve it for W. Or do the same thing in the second one. Usually you do whichever one is easier.
Plug it into the other equation.
And then you plug that into the other equation. So take what you did in step 1, plug that into the other equation, simplify it. Okay. At this point, you should know one of your variables, whichever one you solved for. Okay. You'll know one of them. And then what do you have to do after you know one of the variables? Yeah?
You plug it back in.
Plug it back in. Take the answer that you got in step 2, plug it back in, and get the other variable. Okay, so when you're doing these kind of problems, there's lots of different ways people could go about doing it, depending on how you choose, what you choose to solve for. Okay, so that problem that we did in example 1 that we set up, that's really set up to use substitution. You can't really do elimination very easily on that first problem. Okay, an elimination problem would look more like this. That's a problem you would use elimination. You could also use substitution, but elimination would be faster. Right, so we'll practice both. We'll try some problems like the one I just showed you where you could do substitution, and then we'll also try it with elimination. You should get the same thing. Okay, everybody have the steps for substitution. All right, so let's go back and look at the area and perimeter problem. This is the exact same problem. The only thing I did is I changed it to x's and y's to solve. Okay, but we have 2y plus 2x equals 100, and x plus y equals 300. Okay, which equation here is it easier to get a letter by itself in? The top or the bottom? Yeah, I think the bottom one is easier because you only have to do one thing to get a letter by itself. And Luke, what letter do you want to get by itself?
Y.
Y. So how would you get y by itself?
You would divide both sides by x.
Divide both sides by x. Okay. So now we know y is 300 divided by x. So once we figure out x, we can use this formula right here to find y. 300 divided by whatever x is. But we have to find x first. Okay, so now what do I do with the 300 divided by x?
Plug it into the other equation.
Yep.
So it'd be 300 over x.
So it's 2 times 300 over x. It doesn't matter if you put the whole thing over x or just the 300. That's the same thing. Plus 2x equals 100. How many different letters are in that equation? Just one. It appears twice, but there's only one letter. It's just x's. Now we can solve for x. What's the first thing I would do here?
Multiply 2 by 300.
Okay, so we can put 600 over x. It's 2x equals 100.
Divide 100 by 2.
You can't divide 100 by 2 unless you want to divide this by 2 as well. So if you want to divide something by 2, you have to do it in all 3 spots.
So can we multiply 100 by 600 then?
You could multiply 100 by 600, but you'd also have to multiply the 2x by 600.
Okay.
So that would just end up making all the numbers bigger, but it wouldn't help to get x. Wouldn't help to get the equation the way we need it. I think that's what Luke said first. You could move the 2x to the other side, but the problem is this x here. We don't want to have that x there. You could multiply everything by x. Okay? So when you do that, and you have to do it everywhere, what are you left with?
600 plus 2x squared.
Equals 100x. Now that's what kind of equation? It's a quadratic. So now we just need to solve it. If we can factor it, that's great. If we can't, we can always use quadratic formula. When you solve a quadratic, we always get it equal to 0. So I'm going to put everything on the left. Generally, we like the squared term positive in case you can factor it. How would you move 100x over? Subtract it. And before I even try to factor this, what could I do to make it a little easier to work with the numbers? I can divide everything by 2. So that gives me x squared minus 50x plus 300 equals 0. Still kind of big numbers. I'm going to guess it probably doesn't factor. Okay, unless anybody sees how it would factor. 2 numbers that multiply to give you 300 and subtract to give you 50. So if we can't factor it, or even if you can factor it and you don't see how to do it, you can always do what? To solve a quadratic. You can always use the quadratic formula. What are the 3 letters in the formula? A, B, and C. What's A? B? Negative 50. And C? 300. Okay, so plugging that in, what's the first thing I write down for the quadratic formula? Negative B. All right. Plus or minus, yep. Square root of what? So B squared. I'm going to do that as we go. Minus 4. A is 1, so technically we don't need it here, but put it in. For AC, all over 2A. Okay, so we get 50 plus or minus the square root of, what's 4 times 300?
1200.
And then 25 minus 12 gives me 13. 100 over 2. And I can already tell just by looking at the square root of 1300 that's going to be a decimal. So this probably would not have factored. All right, let's just round it off. So the square root of 1300 is about 36.06. So 50 plus or minus, what did I just say? 36.06 over 2. So let's write down the 2 answers. 50 plus 36.06. Question?
Can't we take out the 2, technically?
Unless we had a 2 on the outside of the square root, then we could cancel it everywhere. But you can't cancel it with the 1300 under the root. Yep. I think I typed that in. Let me check again. So 50 plus 36.06. Okay, Okay, so one answer is 43.03 for x, and the other answer, we'll call it like x1 and x2, is 50 minus 36.06. 36.06, and divide by 2. We get 6.97. Okay, so we get 2 answers for x, which means we're going to have how many answers for y? 2. y1, y2. How do you find y if you know x? Yep. What's the formula to find y directly?
Equals 300 divided by x.
Yeah, use the formula we created. Take 300 and divide by x. So let's take 300 divided by 43.03. And watch what happens. 6.97. Any guess what y2 is going to be? It's going to be 43.03. Take 300 and then divide by 6.97. Or rounding, it comes out a little different. So 43.04. So
Wait a minute.
why did I get 2 answers? Remember the original problem? This was about a rectangle, finding a rectangle.
A rectangle can be placed this way, right, so it goes a long way across the x-axis, or it can be placed standing up on its side, you know,
Yeah.
across the y-axis.
So the top one is a rectangle like this. X is 43, y is about 7. The bottom one is the same rectangle, rotated 90 degrees, basically. That's why we get 2 different answers.
So this is just, this whole section is basically like standard algebra, right?
Yep.
Like this kind of stuff we learned before.
Yep, so this is a little review, and then we're going to get into 3 variables, and then the matrix stuff will probably be here. Yeah. Okay, so that's that one. Let's try this one. Even though you could use elimination, let's do substitution. Which equation is easier to work with if you're going to use substitution? Yep, the top one. And which letter is easiest to get by itself? Y. So it's up to you, but I think the easiest thing to do would be get y by itself in the top. Right, so Brad, if I get y by itself in the top, what will y equal?
5 times 2.
Yep. Y is 5 minus 2x. Now I put a box around that so I remember to come back to it. Because once I have x, I'll fill it in and get y. Okay, and what do I do with 5 minus 2x? For which letter? Y. Now, when I plug it in, what do I want to be careful with here? So yeah, we got to be careful with the signs. What else? Well, somebody tell me, how would I write this down? What would I write first if I plug this in?
2 equals.
Well, that'll be at the end, equals 2. Yeah.
Then it would be 3x plus 2 parentheses
Yes.
5 minus 2x.
Yeah,
Boil up.
that's what I was looking for. Just to make sure we put parentheses there. Okay, to remember that 2 is distributed.
Couldn't you just distribute it to go 5, so 10 minus 4x?
Yep, so it's 10 minus 4x. And then what do you get when you combine your x's on the left? And then move the 10 to the other side, and you get
12.
negative 8. So what's x? 8.
Wait a minute. What was that again? Oh, let me see how you did that.
So 3x minus 4x is negative x.
Oh, okay.
And then 2 minus 10 is negative 8. Okay, now what do we do with 8? Yeah. Plug it in right there. So we get y equals 5 minus how much? 16. 2 times x, and x is 8. So what's 5 minus 16? Negative 11. And so when you write your answer on the test, you can write it just like I did here. Or if you were to graph the top and the bottom, these are both lines, what would happen at the point 8, negative 11 if you graph both those lines? Okay? That's where they intersect, yeah. If you graph, you'd have to solve it for y to plug it in, get it in y equals mx plus b. But if you graph each one of them, 8, negative 11 is where they cross. Any questions on that? We don't usually solve by graphing because in Algebra 1 they practice it a little bit, but solving by graphing can be kind of a pain if your answers are decimals. You're never going to be able, unless you use a calculator, to get precise decimals graphing by hand on paper. So. All right, so elimination. Okay. That's the other way we can solve systems. Elimination is a lot more user-friendly when you start to get into more complicated problems. Okay, substitution is not. Okay, substitution starts to kind of become a pain when you get into like 3, 4, 5 variable problems. But elimination is the method that when you use a matrix, matrices are based on this method. Okay, and it works. It's pretty efficient when you get into more complicated problems. Bless you. So the goal with elimination is you're going to add multiples, or what we call linear combinations of one equation to another equation to try to get variables to cancel out. Okay, how do you get variables to cancel out? Basically, if you had equations like this, 2x minus 3y equals 4, and negative 2x plus y equals 10. This would be a system that's set up for elimination because you have a positive 2x on the bottom, positive 2x on the top, negative 2x on the bottom. When you add them vertically, they cancel out. You add everything vertically when you do elimination. Okay. If you don't have a number and its opposite, okay, right away, let's say you had 2x plus y equals 7 and x minus 3y equals 8. You can still use elimination, but you're going to have to multiply one of these equations by a number to get them to be opposites. Okay? I usually do opposite. I don't usually do the same. So we'll just stick with getting them to be opposites. So does anybody see what you could multiply the top equation by to make the y's opposites? 3. So you could make it 6x plus 3y equals 21. And then you'd have positive 3y, negative 3y, and they would cancel when you add vertically. Okay, so that's always the goal. Try to get the same letter to have opposite numbers in front of it. Sometimes, like we did here, you can get away with just multiplying one equation by a number. Sometimes you have a problem where you have to do both. If you had something like you can't, unless you want to use fractions, which we try to stay away from, you can't really get the x's to be opposites in this case. What I would probably do is multiply the top one by 5 and then the bottom one by negative 3. And then you could make the x's opposites, 15 and negative 15. Okay, so sometimes it's necessary to multiply both equations by a number. Okay, and just make sure you remember when you multiply, you have to do it in all 3 spots. Or if we have more variables, you have to do it in all 4 spots or 5 spots, however many variables you have. All right, so let's look at this one. Okay. in this problem, could we get away with just multiplying one equation only? And I don't want to use fractions.
No.
No. 3 is not a multiple of 5. 2 is not a multiple of 3. We can't really do that. So let's pick a letter that we want to get to be opposites. Right? Do we want to try to get the x's to cancel or the y's? Y's. So let's take the top equation, and what could you multiply that by? You could multiply the top by 5. Okay, let's do that out first. Luke, what's my new equation if I multiply by 5?
The 10x plus 15y equals 25.
It's 25. All right. And now we have to multiply the bottom equation by a number. It can be a different number to try to get the y's to be opposite. Negative 3. Okay, so if we multiply that by negative 3, Sam, what would my new equation be?
It would be negative 9.
Careful, negative 3 times negative 3x.
Oh yeah, positive 9.
9x, yep.
9x, negative 15y
Yep, we get negative 15y.
equals, wait. Oh, 63.
And just be careful because it's a positive times a negative.
63.
Negative 63. Okay, now add those up vertically. Okay, add them up. 15, negative 15. Okay, that's gone. 10x and 9x gives me 19x. And then 25 minus 63. So I get 25 minus 63 is negative 38. Okay, and then my last step, and then I'll know x. Yep. Divide by 19. 19. So what is x here?
Negative 30 over 19.
And that's actually going to come out nice. Negative 2. Now do the same thing you did last time. Pick an equation, whichever one is easier, plug it back in, and solve. Which equation do you think is easier to go back to, the top or the bottom? Well, the top one has all positives, so that's kind of nice, and the number on the other side is smaller than 21. So it doesn't matter, but I would say the top one is easier. Not always. What's 2 times negative 2? Negative 4? Plus 3y equals 5. Okay, next step.
Or add 4.
Add 4. And last step. Divide by 3. What's y? 3. All right, so both methods, either substitution or elimination, will get you the answer. Sometimes one is easier than the other. If I have a variable that's already by itself, sometimes I use substitution. If they're set up like this, where you don't have a variable by itself, and if you tried to get one by itself, you'd have all kinds of fractions, then I usually try elimination first. Okay, so any questions on that? All right, so when you're solving the systems that we're solving, there's 3 types of things that can happen. Think about if you draw 2 lines. What's one thing that can happen when you draw 2 lines in terms of where they cross each other? Okay, that's a special case of what I'm thinking of. What happens when they're perpendicular? They cross once. Yep, they cross 1 time. What else could happen if you draw 2 lines in terms of where they cross?
Parallel.
They could be parallel. They might not cross. Okay, so if you had a system that was parallel, there'd be a no solution. What's a third thing that could happen? Well, if there's two solutions, what would that mean?
It's not a line.
Yeah, if you had like a parabola in a line, you could get two solutions. But two lines can't cross each other exactly twice. But they can do something other than a one solution and no solution.
You can have an infinite amount of solutions because they're on top of each other. right?
Yes, you could have an infinite amount of solutions if you graph two lines that are exactly the same. So that's the three things that can happen when you solve a system with two equations and two variables. One solution, no solution, infinite solutions.
Infinite possibility. Sean came across birthday today, so you're.
It is? Oh, happy birthday.
Thanks. My son gonna tell you, my son gonna tell you.
Okay, looking
That's pretty good.
looking at that equation, anybody notice, or that system, does anybody notice comparing the first one to the second one? They're really multiples of each other. Or are they, or they're close, not quite, because the signs are off.
Yeah.
But-
The signs on the X's are.
Yeah, the signs are off. So let's see what happens when we try to solve it.
Everything answers.
What happens, well, what could you multiply the top equation by?
Negative.
Okay, we could do -3. Okay. The only thing is if you do -3, you're going to get numbers that are the same. What if you wanted to get numbers that are opposite? Yeah, use +3. And watch what happens. You get 6x minus 9y equals 15. In the bottom, -6x plus 9y equals 10.
Uh-oh.
What happens when you add your x's and your y's? So when all your variables cancel out, then you're a special case, either no solution or infinite.
I don't know what about the special case.
Sorry, it's fine.
So what's on the left?
0.
0. What's on the right?
25. So no solution.
So when you get a statement that's false, it means that there is no solution. Don't write false. The only things you should write are the exact solution, like we found in the last problem, no solution, or infinite solutions.
Oh, wait, so I can't put not applicable?
Nope. That doesn't really tell me whether or not there's a solution. Yeah, just write no solution. Okay. How about this one? Are these equations multiples of each other?
Yes.
Yes. And the signs do match.
Infinite solution.
So what could you multiply the top one by?
Negative 2.
Multiply it by -2, and you're going to get, it's pretty much exactly the same, it's the same equation. -2x plus 6y equals -2, and -2x plus 6y.
Would it be +4?
Yeah,
Multiplying -2 by.
yeah, I forgot the last one. So when you do that, if they come out exactly the same, they're the same equation, they're the same line. So how many solutions would that be? Infinite. So for that, just write infinite solutions. Or if you went through and solved it, you would end up with this. 0 equals 0. Okay? If you subtract these from each other, you get 0. If you subtract 6y minus 6y, you get 0. And 4 minus 4, you get 0. Okay? That's basically what happens here. Okay, so any question on the special case? All right. So the last thing we're going to look at, and this is what's going to get into more next time, is solving with 3 variables. 3 variables, we're not going to do substitution. You can. It just starts to get kind of, yeah, it gets kind of messy. So the way you do a problem with 3 variables is you are going to pick a variable to eliminate in two of the equations. So you're going to pick two equations. You're going to forget about the third equation for now. Okay, so something like, out of those three, pick two. Forget about the third one. Then eliminate one of the variables in the two equations you just picked. Once you do that and eliminate a variable, you're going to be left with two equations and two variables, and you're going to turn a problem that's like that into a problem that's like that. You're going to be left with just two equations and two variables. And you solve that just the way we did before. The only extra step is when you're done, you have to substitute back in a couple times. So you've got to find x, then substitute back in to find y, and substitute back in to find z. So you just don't forget to find the third letter. Okay, a lot of times what I'm going to do is I have it come out to nice answers. Okay, so if you start getting really, really bad decimals, like on a test problem, double check you didn't do something wrong with arithmetic. Because usually the answers come out nice. I mean, it might come out to like a half or a 0.5 at the worst, but it's not going to come out, not like the area, not like the rectangle problem. Those numbers were pretty bad. All right, so let's pick two of those equations to work with. Call them equations 1, 2, and 3. Which two do you want to try to work with? One and three? Okay, so we're going to work with 1 and 3. So I'm going to write them down so I have them. 2x plus 3y minus z equals -1. And x plus 4y plus 3z equals -8. What letter do you want to try to get rid of here? Okay, we could get rid of y, but we're going to have to multiply each equation by something. Let's just pick a different letter. Okay, let's do x. What could you multiply the bottom equation by that would get rid of x? -2. So this one I'm just going to copy over and keep it the same. And the bottom one, if you multiply everything by -2, you get -2x minus 8y, yep, minus, oh, I'm sorry, that'll be a, no, that'll be a minus what? 6z equals 16. When you add the x's, they cancel out. Okay. What do we get when you add the y's? -5y. How about when you add the z's? -1 minus 6. -7z. And then add the other numbers.
Wait, did you pick 1 and 3?
I hope so.
Because on top, it's 3, it's -3.
Oh, is that the only mistake we had, just the sign?
Yes.
Okay. Well, good, we caught that early. So that would change this
Plus 6.
plus 6.
Hey, I ended up being right. Thanks, man.
Yes, thank you. Everything else looks good? Okay. 17. Okay, so I'm going to put a box around that. Because now we have one equation, and we got rid of a variable, a y and a z. Okay. I want to do the same thing again. I want to pick, but don't pick 1 and 3. Pick a different combination, and you have to get rid of the z
Also,
again.
1 and
you didn't change anything on the top formula, right?
I didn't change anything on the top.
You
put 1 is positive on the other side, it's -1.
We gotta be careful here. Thank you. Yeah, see, if you make a mistake with the sign, that messes everything up. We would have figured out when we got some pretty bad decimals that we did it wrong. If you want, now everything is a multiple of 5. You could divide by 5, and actually we can simplify it a little bit. You don't have to do that, but it's just going to make the numbers easier in a little bit. So I'm going to call that equation 4. All right, let's pick 2 other ones, and let's do the same thing. We have to get rid of x. What would be 2 other equations we could pick to get rid of x besides 1 and 3? 2 and
1, 4.
I would do 2 and 1 only because the 2 and the 3, you're going to have to multiply each of them. I'm just trying to make it easier.
So,
The 2 and the 3, because then you could just multiply by a -3. So let's take 2 and 3. I'm just going to copy them down. 3x minus 2y. Double check my signs because I have a little problem with that today. It's 15. And 3 is x plus 4y minus 3z equals -8. Okay. What could we multiply the bottom by to get rid of the x's? Yep, -3. So keep the top the same. 3x minus 2y plus 2z equals 15. And what does the bottom become? -3x. Yep, minus 12y. Good, plus 9z equals 24. So now, x's are gone. -2 minus 12 is -14y. 2 plus 9 is 11z. And 15 plus 24 is 39. Let's just double check, make sure we added right. All right, I think that looks good. Anyone else think it doesn't look good? All right, so now look at equations 4 and 5. This is just like a problem we did in the past. 2 equations, 2 letters. Hopefully when we solve it, it comes out nice. I think it does. So now we're working with just those 2. Okay, let's write them down. So solving 3 variables, it's not harder. It takes longer. There's no question. It takes it does take longer. But it's the same thing. You're just doing it a lot more times. -14y plus 11z equals 39. Okay, what letter do we want to try to get rid of here? Y or z? Either one is just as easy. Y, okay. What would you multiply the top equation by to make the y's opposites?
14.
-14.
-14. Okay, so that's going to give me 14y minus 14z. And what's 3 times -14?
-42.
42. And the bottom one, did we do anything to that? No. -14y plus 11z equals 39. So now we'll add them up and hopefully nice things start to happen. What's -14 plus 11? -3z. And what's -42 plus 39? -3. Divide by -3. Divide by -3. And we have our first letter. What's z? Z is 1.
Wow, all that work for
Only
one.
one letter.
Well, that's the hardest one to find. Now the other ones are going to be easy. You just have to plug them back in. So to find y, what equation could you plug back into? 4, right? It should be, just plug in z and solve for y. Okay, so using equation 4, negative y plus z equals 3. What's z? What was it equal to? 3. So negative y equals negative 2. What's y? Negative 2. Okay, so once you get the first letter, the other two are going to come very quickly. And now what would you plug back into to get x? You could plug it into either one of them. Let's do 3, because the x doesn't have a number in front of it. X is already by itself. So x plus 4y. Can somebody tell me the rest? X plus 4y minus 3z. And negative 8. Okay. 4 times negative 2. Negative 3 times 1 is negative 3. What's negative 8 minus 3? Negative 11. And then add 11, x equals 3. Okay, so all the work really that you have to do is just to get the first letter. Once you get the first letter, you're like 90% done the problem. The last 2 letters are very quick to find.
So it's 1, 2, 3 is what y is.
X is 3, 3, negative 2, 1.
3, negative 2, 1.
Those are your answers. 3, negative 2, 1. Okay.
Yeah, well, how creative that is.
All right, so that approach that we use, okay, to solve it, elimination, probably that's the highest amount of variables you'd want to use it with. Okay, beyond 3 variables, we're going to want to start to use a matrix, okay, to organize everything. Okay, the reason we want to use a matrix is because it cuts down on the amount of writing. Okay, when you use a matrix, you don't have to write any letters. So all those letters we kept writing, we would just write numbers. So if this was a problem I was solving and I wanted to write it as a matrix, all you have to do is copy down the numbers that are in front of the letters, not the letters themselves. And this side is 410. Okay, so next time we'll talk about some of the same problems we just did, but it's going to be a lot easier and more efficient to do it as a matrix. By efficient, I mean less writing, less steps. Okay, but that won't be till next time. So for the problem on the test, I think there's one that's a 3 by 3. Everything else is just 2 equations and 2 variables. But you will have one like that. And keep in mind, if I have an equation and I leave a blank spot, that's already a 0. So you could use that to your advantage to speed things up. If an equation already is missing a letter, it cuts down on like half the work you have to do. So try to use that to help you. All right, so homework tonight back in the book, okay, not in the packet. It's 541, 1 through 19 odd.
All right, so you're going to see me after school today.
Yes, I will be after school today for extra help.